Hello, I'm Joanne Sanford, and today I'm going to talk to you a little bit about warm-ups in your math class. I don't claim to be an expert on all things math, but I have seen the power of a good number routine. So I can share with you today a little bit of that experience and why I make the instructional choices that I do and how it has impacted my classroom culture, my classroom climate, and most importantly, how it has impacted how students see mathematics and see themselves as mathematicians. So let's get started. So, what is a warm up? I don't want to get hung up on defining what a warm up is. But when I say warm up, I'm talking about any of the number routines or math questions that happen at the start of your class that may be independent of your regular lesson. They may or may not be part of the same unit you're currently studying. It's what you do at the start of class to get the math rolling, students flexing those math muscles. There are so many great math warm-ups out there already made. There are even experts showing how to use these ideas in your classroom and also how to adapt them for online learning. So I won't talk too much about these here. What I do want to share are some ideas on how to max out simple routines and how to use them to promote a productive classroom culture. Aside from the math that is practiced, discussed, or examined in a warm-up routine, I'm hoping that I can also highlight how some teacher moves in the facilitation of warm-ups can help build that great atmosphere in your class and help set those critical classroom norms that all students have a voice, where partially thought out or incomplete ideas are welcome, that mistakes are expected and help us all learn something, that we can disagree, but we do so respectfully, where we listen to each other and build on each other's ideas, and where we work as a team towards understanding each other's thinking while testing, representing, revising, solving, improving, and doing all that in different ways. The right routine coupled with the right teacher moves can help move all students forward. Students may not all get the same thing out of the warm-up, and that's okay. If students start to see patterns and connections between the topics that we discuss while building their confidence and number sense and joy of math exploration, then the warm-up's a good one. When choosing or designing warm-ups, there's some things that I always try to keep in mind. The goal, of course, whether it be a certain math goal or mindset of the students or certain behaviors I'm trying to promote, and what would success look like? Can everyone participate? And what are the norms that I have to review before we get started? How much time is this going to take? If it goes over 10 minutes, is that okay? What materials do I need? And if I'm using certain materials in my classroom lesson, maybe I can incorporate those in my warm-up somehow. What will this warm-up tell me about my students? And also, what will this warm-up tell my students about themselves? All of these things I think about when I'm designing a warm-up, and it's some of the things I reflect on when I'm thinking about how it went later. By the time many students reach middle school, they may already have pretty fixed ideas about what it means to be good at math and whether or not they are good at math. In my experience, many students equate math awesomeness with the speed of getting the right answer and usually assume there is only one right answer or one right way of doing things. And warm-ups are a really good way to help students revise these ideas. Number of the day. This is one of my favorite number routines. I've been doing this routine on the first day of school for as long as I can remember. I like it because it's not intimidating. Everyone can participate. It tells me a lot about my students, and it helps students see quickly how I conduct my math class. This is a routine that can take a whole class or just 10 minutes, depending on you. I usually stick with this for a chunk of time the first time around, and then shorten it up as students become familiar with the format. I may narrow the parameters or focus depending on the needs of my students. Another great part of this routine is that it naturally leads into noticing regularities, extending patterns, comparing operations, and using some of what you notice to make future questions easier instead of being stuck in procedures and algorithms. This is how it might typically unfold in my classroom. I tell my students, you will need a piece of loose leaf and a pencil. I'd set the expectations. For this warm-up, we were going to work quietly on our own at first and then share out later. I might interrupt to give some hints, and I often get really excited and share when I see something awesome. I call this warm-up the number of the day. I will give you a number that is the answer, and you will write the questions. Everyone ready? The answer is 5. I usually start walking around, looking over shoulders. Some kids get right down to business. Others are not sure what to do. I say again, the answer is 5. Write me some questions. Someone usually asks, like 4 plus 1? And I say, yep, and then off we go. I might see something like this. When I see some pencils slowing down, I might say, oh, I see some subtraction over here. Does everyone have some subtraction on their page? And then, oh, I saw someone with multiplication and division on their sheet. Nice. A little later, I might say, wow, some decimals and fractions over here. And I might say that even if I don't really see them. And then, wow, I just saw a picture that means 5. Can you all include a picture that means 5 somehow? And then, oh, an expression that has more than one operation. Or, wow, all 4 operations. I usually get a little flurry of activity after each comment. I kind of gauge the room, and when I see things are starting to slow down, I pass out some markers. I direct students to my sideboard usually, a spot where I can leave their work up for a few days. I ask the students with the markers to come on up and share something that you wrote. This can be intimidating for some kids, but the fact that there's usually 5 going up at a time helps. And lots of kids are still focused on their own list, which helps too. They don't feel like all eyes are on them. If anyone's looking a little nervous, I might add, write something you think everyone has on their sheet. That comment saves some kids from thinking their work is too simple or not creative enough. I direct those with the markers to give it to someone else in the class when they're done. I might ask those students to write something new, or they could put a check by something they know for sure is right, or a question mark by something they want to talk more about. Here I'm trying to highlight the idea that we can help each other out and that we all look critically at each other's work to verify and to understand. I don't want students always looking to me to confirm if an answer is correct or not. That's something we can all do for each other. I might ask if anyone has something they think no one else has. This gives me a little window into what some students think is difficult or creative. Then I might push some vocabulary a little and say, I thought I saw someone with an expression that had 5 addends. Anyone? Or could anyone make an expression with 5 addends another way? What about 10 addends? Then I might ask, does anyone see any expressions up here that are related? Can you come up and connect with a line to expressions that are related somehow? And then we talk about those connections. We usually get a few pictures on the board as well, and this often leads to a few students trying to draw the most believable beaver for a nickel picture, which always gets some laughs. As you can see, this is something that can go on forever and in vastly different directions depending on what the students contribute and what the facilitator chooses to highlight. It can be steered a lot of ways. I usually try to focus on getting everyone up and participating, keeping it light and fun, making sure we see connections and that the end product is messy and awesome. My classroom is kind of nice. It's neat, organized, and pretty. This can be calming for some students, but it might be intimidating for others. I want to highlight that math can be messy. We bust numbers apart and put them back together. We can see connections and have this crazy first draft, and then pull out some ideas and reorganize later. It is a process. I often build from this routine for the rest of the week. The second day, I pull out some of the addition expressions, and we talk about and try to articulate a pattern. Here I let the kids do the talking. I record their words and get the others to repeat, model, and prove with pictures or blocks, rephrase, and refine. We focus on clarity. Seeing and stating the pattern is a nice lead-in to some great mental math where we make equivalent expressions that are easier since we've noticed and stated the regularity that happens with addition. Keeping the numbers small helps us focus on being precise with our language and makes ideas easy to test. If we are confident that this pattern is correct, we can build on that solid foundation quickly. That might look like this. I might ask students if they notice anything. I usually hear, "It's a pattern." What pattern? Someone usually comes up to show me that it goes down by one here and up by one here. We might extend the pattern in both directions. We might model the expressions with blocks and discuss where we see each addend in the representation, how we see that it's adding in the picture, and how we can tell that they're equal. It's a quick talk, but it's important to point out, I never assume we can all see it. I ask, do we have to just increase by one, or could it be any amount? And we refine our statement. I might then pull out a few expressions and write them like this. I find students often treat an equal sign like an operation that means, now work it out and put your answer here. Seeing equal expressions written this way might be really helpful. Another day I might ask, are these equal? And how can you tell? Here I'm trying to get students to notice the regularity we've discussed already. And they point that out instead of proving by computing both sides. I'm hoping then that when the numbers get more difficult, we can use some of these methods of adjusting to make things easier. The next day or week, depending on the students and how things go with addition, we might pull out the subtraction statements and continue the pattern both directions. We may articulate that pattern and compare it to addition and think about how this regularity can help us solving other subtraction problems. This may seem like an easy starter in middle school, but in my experience, many students seem tied to algorithms and don't often adjust expressions mentally to make them easier. It's a little used but highly effective mental math strategy. If you've taken the time to notice a regularity, articulate it, represent it, and practice using it. This is later in the year when we used the number of the day with 6 4/10. And I use this routine often. We might focus on one operation or how we can use one operation to help with another. One student pointed out what you see here in blue, and he was so proud to see that two operations could be related to each other. I think the key is to start with something simple and build on that gradually. It's really awesome when students start to see connections between what they know already and new sets of numbers. So with this routine, everyone can participate at their own level. It's a gateway to lots of mental math strategies and a deeper understanding of the operations and how they connect to each other. It can extend patterns to new sets of numbers so students can see those connections and not think that things like operations with fractions or decimals are a completely new idea. It helps them articulate those generalizations, and it's minimal prep. Find your group. This is a routine I often use when I want to get my students in groups for the regular classroom activity. I have a deck of cards made and hand them out to the students as they come in and tell them to find their group. The decks I use most often include concepts I want students to have automatically and at their fingertips, like the one seen here showing some basic fraction, decimal, and percent equivalents. There's a bit of urgency since students want to find where they belong, but no real panic since everyone is up and moving. I can be precise with my directions, like make a group that shares an equivalent or common amount, or I can say just find a group. The vague directions intentionally leave room for interpretation. Usually when students see this routine for the first time, they group up as intended or expected with equivalents, even if I'm not precise. But like many of my other routines, I try to push back a little to show that there might be more than one way to interpret the directions. I could then ask, all right, find your group again, but another way. This time, some students just sit there unsure of what to do next, but there's always a few to get going and spur the rest to action. I ask the students when they're settled what makes them a group. I might have students tell me that their group is all fractions, all decimals, or we are all pitchers. Another way I use this deck is ask kids to find a group of 3 or 4 where everyone in the group has a different value. Then they could arrange the cards from least to greatest and prove it or complete another task. Later in class, if I want to have some students on Chromebooks while others are working on something else, for example, I might say, okay, all kids with an amount less than half do this. Lots of ways to group and regroup. What's really great is when students become familiar with the routine and they want to be in a group with certain people. They try to argue why some unlikely matches go together, which is super fun. Other decks I've made include expressions that can be simplified quickly to make numbers 1 to 9, or might have an equation that when solved will be one of the numbers 1 to 9. That number could correspond to their group. These I can make at a variety of levels of difficulty to correspond to the needs of my students and could all be the same topic like operations with decimals or integers or a variety of topics. Other cards I have share common areas or attributes. Here's some cards from a deck of coordinates. When students find their group, I ask everyone in the group to confirm that everyone's in the right location. Then they might be asked to create another card that would be part of their group too. Here's a sample group that could be called quadrilaterals. And here's one that could be called hexagons. In this deck, kids can group with other regular polygons, or what students often call normal shapes, as well as groups with a common amount of sides. This one is particularly helpful so that students can see examples of shapes that they may not see as frequently, or shapes oriented in a variety of ways. With this deck, I usually ask kids to give their group a name, make a new card or cards that would belong to the group, and if I have some time, I might also get them to talk about what is the same and what is different, which is a great way to review vocabulary, or I could launch a discussion on the sum of interior angles. Here's a sample group that could be called Group 5 from a deck where answers are all 1 to 9 to go with group numbers. From here, though, I could talk about halving and doubling, get students to prove these expressions are equal with some representations, make some cards that have fractions that are not unit fractions or ones that include some decimal operations, or wherever I want the discussion to go. What I like about this routine is that all students can and are compelled to participate. They help each other. There's an air of teamwork. It can send the message that precision in language is important and can lead to all kinds of noticings and other connections. Before I go ahead and spend time on making decks on cardstock or ones that are more permanent, I test them out using slips of paper or Post-its. Then I can reflect on what worked well and what didn't and make adjustments. What comes next? This warm-up routine focuses on patterns. The patterns could be in numbers or in pictures, and the pictures could be shapes or any manner of manipulatives. I love using this routine to help students see the connections between numbers and picture patterns and help start looking for ways to generalize. This routine can help reinforce the message that using pictures and manipulatives to make sense of or to represent math concepts is not just an elementary topic left behind now, that we can also think in more abstract terms. Like other routines that I do, I keep in mind that students are coming from a wide variety of math experiences. I try to start simple, build confidence, and make sure everyone feels like they have something to offer, and then use what I hear in the responses to take it up a notch. As always, students might get different things out of the warm-up, and that's okay. Here's a picture that I grabbed from mathlearningcenter.org. If you follow them on Twitter, they post lots of pictures for this and other math routines that can be adapted for your class to account for the needs of your current students. This one they listed as grade 3, but I would definitely use this in my grade 7 or 8 class too. With this picture, there were a few questions given to guide the activity. What patterns do you see? What are the next 3 pictures in the sequence? What picture would come before the first picture in the sequence? I'll give you a minute to figure that out for yourself. While students are thinking about these questions, I'm circulating and asking about what they think or notice. I try to talk to those students that are less likely to share out to the class. If I hear something cool in what they say, I'll tell them it was cool and ask if I can call on them when we discuss as a group. Hearing from lots of students helps build that community of learners. After a few minutes of think time, I might get students to share out to the class. With this, I might also ask, what part of the pattern did you look at to get your answer? I always seem to gravitate to later in the pattern and then test from there. Very rarely do I look at the first or the second picture. So I wonder what students do and what they see. I ask if they've used those manipulatives before and how they use them. I asked, did anyone change these pictures to numbers to help figure it out? And we talk about how that could be done and what would the numbers be. We might talk about what these base 10 blocks are worth and decide on a legend, and later might change the legend a little and see what happens to the pattern. I also asked what the 20th picture would be in the pattern, and if you would have to build it to decide, or how do you decide? How could you figure out any picture in this pattern before or after what you see here? So we start simple and gradually take it up a notch. There are so many great picture patterns at visualpatterns.org. I use them a lot in warm-ups. Aside from generalizing, we also discuss how we see the pattern changing from one picture to the next. It's so helpful for students to hear the ideas of their peers and how different interpretations or descriptions could be correct. For example, with this picture pattern, some students might imagine like spokes on a wheel, like I have here in red, and look at the hexagons that fall in between those spokes, while other students might be looking at these side measures and seeing how those change. So talking about all these different ways is so helpful for students, because what I might see as the change in one picture to the next might be very different from what they see, and both things are correct and they should be able to hear all those things. For number patterns, it could really be anything. It could be increasing or decreasing patterns involving fractions, decimals, integers. Could be adding, subtracting, multiplying, dividing. And in my experience, students seem more invested to figure out and test in a pattern situation versus giving them a collection of equations to solve. This routine can be done anytime with any unit. I love Venn diagrams. I think it's really useful for students to make connections between topics and numbers, and Venn diagrams are one way to represent those connections. Here's one example of how I use them in warm-ups. The Venn is given without the labels, and students have to figure out what the label should be. I've done this warm-up different ways. Sometimes I have the numbers coming in one at a time, like they do at slowrevealgraphs.com. and ask students to write down and revise their ideas on their own as the numbers show up. Then they turn and talk with a partner or partners or share out. Often, I'm in a class where some are finished quickly and many need more time. If that's not handled well by the teacher, you can reinforce the widely held idea that math is all about getting the answer quickly. How I handle that in this situation is I have those students who are very confident that they have the correct answer write down some more entries that could be placed in each section, or ask, is there a number here that really helped you more than the others in getting your answer? That way, everyone has time and a chance to keep revising and confirming their ideas until we're ready to share out our thoughts. As always, I try not to be too helpful. I let the students test and confirm for each other as we work towards a consensus. Have you figured this one out yet? Here are the numbers that many students claim are the most helpful. And this is the consensus we reached in my class. Another way I've used a Venn diagram is with Post-its. I might have a blank but labeled Venn on the board when the students come in and give them all a few Post-it notes. Students are asked to write a number and place it where it belongs in the diagram. Students then go on up when they have something and place it, and back to their seats to create another. Like other warm-ups I do, students are compelled to participate, and they can do so at their own level while everyone's moving around. After there are a few numbers already in place, I ask students while they're placing a new Post-it to put a check by someone else's that they can confirm is correct, or a question mark by one they're unsure about. Conversations and debates naturally rise, and revisions happen, and I try to stay out of it. This is a beauty of a Venn, suggested by my colleague, Valerie Target. I did it as a warm-up that snowballed into a week-long discussion. Why don't you take a minute now to write down an entry for each part of this Venn so you can see where this warm-up is heading. After the process of everyone writing numbers, our Venns started looking like this. We had to move on to something else, so I saved it and we continued the warm-up the next day by giving out a couple more Post-its each and asked students to write a number for some of the lesser populated parts of the Venn to even things out a little. Eventually, one of my students thought out loud that maybe it was not possible for a number to be divisible by 4 and 9 and not 6. Others piped up and said, I'll figure it out. I'll find one if we can have 5 more minutes. The warm-up the next day became find a number for this spot, or if you think it's not possible, create your argument to prove it. We left it there again with no resolution. The next day, students were given Post-its, and we agreed that their thinking could be one of 5 options. Yes, it's possible, but I don't have any proof yet. It's possible. My proof is. No, it's not possible, but I can't explain why yet. No, it's not possible. This is why. And the final option, I'm still deciding, and this is what I'm thinking so far. So that day for their warm-up, students had to write their name on a Post-it and include their current thinking. Here are some examples. The final day was a convince me prompt, where those that argued no number could fit in the spot made their case to the class. Others asked questions for clarification and restated ideas in their own words until we came to a consensus. With Venn diagrams, you can compel all students to participate. You can review and maintain some key concepts that you've already looked at already, like factors and multiples of numbers, divisibility rules, and so on. You can dig deeper in some of those topics that can be very procedural and start to see connections between topics and numbers. And it can promote constructing arguments and formulating generalizations. And with many of these, it's very quick with minimal preparation needed. The question we just did happened to be related to a Venn diagram, but it's an example of another way to use a warm-up. When you have a great question and want to let students sit with an idea for a while and let it marinate. Some students will get an answer right away, while others will get it on their own if you just give them a little time. Having a question unfold a little at a time over a number of days as the warm-up activity allows that to happen, and it keeps the students that get it quickly from stealing the learning from their peers by revealing the answer too soon. Those students that used to tune out since someone would always get and reveal the answer before them start to engage too, since time is not a factor. And when kids can have time to work through an idea on their own, they're more invested in the resolution and really listen and hear their peers during the explanation, and the concept sticks. And that listening to their peers, that's something else I try to promote during warm-ups. Having peers verify or question results is really key. No one is looking to me anymore as the expert to provide all the answers. One of the best things I have done to improve my teaching practice is extend my professional learning network on Twitter. This is one person I follow, Howie Hua. One thing that Howie often does is share really interesting prompts. I try them myself and read through what others post. It's always amazing to me how creative people can be with math, and I like to try to bring that idea of creative problem solving into my classroom. When I'm responding to these prompts and reading through answers, I'm always thinking, can I use this somehow with my students? Would I have to change it or should I alter it? Is this a warm-up or a lead into a lesson or both? Here's an example. Howie writes, you have the ability to change exactly one thing, number or symbol, to make this simpler for you. What would you change and how did it make it simpler? Solve your new exercise. Take a minute to try that on your own. What would you change to make this simpler? Here are some of the responses that I thought were interesting. Can't get much simpler than this one. I like this one too because I never would have thought of it. This was more in the realm of what I was thinking, working with the denominator somehow. And this is exactly what I did. I took the 3 from the denominator and made it a 4. And I like how Fawn brought up the idea of common denominators in her response. When we investigate dividing fractions in my class, we look at multiplying by the reciprocal as well as using common denominators. And I like this prompt because I feel like it's a way for the students to arrive at that idea of common denominators making things easier instead of me just showing them. So what I might do in my classroom is present that prompt just the way Howie did for the first day. And maybe on the second day, I might change it a little so that they're just directed to change a number to make it simpler. I find a lot of students shy away from division, especially division with fractions. So I want to keep the division and see if they can make it simpler. I think we could get to the spot where the denominators would come up and I'd be asking, why does this make it simpler? and have a conversation about that. And really let this question sit with them. So having the same denominators makes dividing with fractions easier. I'd ask too, how can we use this idea when we have a dividing fractions question? And from here, this might lead into an investigation of some dividing expressions that maybe we've tried already and we know the answers, so we can just test out a new method and be sure that it works. Anytime that we can have students come up with an idea to test or be led to that instead of me just presenting it, I think is a win. Here's another great prompt from Howie. You can change one thing to make this statement true. What would you change? Be creative. I love that this is about fractions. The more fraction chats I can have with students, the better. And I love that he uses inequalities. Students don't see these enough and always need reminding about what they mean. And I love the encouragement to be creative. So you tried first. What would you change to make a true statement? Here are some of the responses I particularly liked. Change the 3s to 5s. This is kind of along the lines of what I was thinking. Make that 3 in the numerator much bigger, or the 3 in the denominator much bigger. This one was my favorite. With these units in place, it's a true statement and it's very obvious that it's true. I think the students would really like this one. Again, a nice simple change that makes it obviously true. And looking at the operation, when I saw this response, it gave me an idea of how I might use this with my students. My first question would be, is this true or false? And prove it. I'm not convinced my students would automatically know that this is a false statement. I know some students would work out that 3/4 minus 2/3 and try for an exact answer, but I would encourage and push the idea we don't have to work it out to prove if it's true or false. And I'd ask, can someone explain how we can decide without computing? I'm sure some students would draw some pictures, use some grid paper, or grab the fraction circles or pattern blocks that I have handy. But I know some other students of mine would also say something like this. 3/4 minus 1/4 is equal to a half. So if we're subtracting something larger like 2/3, this can definitely not be more than a half. I'm thinking of another student I had this year that would always change fractions to decimals. So I'm sure that he would come up with something like this as proof. And it really makes sense in this situation. I try to max out this conversation of proving truth or that it's false until I was convinced that everyone was solid with the idea that this was false and could prove it in any number of ways. That might be all for the first day, and the next day my prompt might be just like Howie's, change one thing to make it true. The next day, still, I could use the same prompt and direct students to change the operation. In my experience, students are more prone to change a number than an operation, and that might indicate that they don't really have a firm grasp on how the operations are related to each other, what patterns they see in operations, or how operations change when the domain changes. I really use this warm-up as a way to underline the fact that division doesn't always make answers smaller and multiplication doesn't always make things bigger. Students really have a tough time letting go of that idea, so the more we talk about that, the better. What do you think? How would you use this with your students? Fraction talks. Building number sense around fractions is so important. Many students seem to fear fractions. They're suspicious of them. They don't act the way other numbers do sometimes. They make students question the things they thought they could hold on to, like multiplication makes things bigger. I always begin my work with fractions using lots of manipulatives like pattern blocks, fraction circles, and tangrams, and we do lots of warm-ups where we talk about fraction amounts and relationships in pictures. The goal of these warm-ups is for students to be able to talk about fractions while automatically using equivalents without having to think too much about it, and know and are confident in answering questions like, what's half of a fourth? And what's 3 pieces the size of 1/8, without necessarily thinking about operations. Fraction talks help achieve this. I have a couple of sources for fraction talks and use the materials a couple of ways as warm-ups. The first is Tangram Fractions by Fulton and Lombard, and the second is the pictures from fractiontalks.com. I'll share with you how I use them. I usually start with all students having tangrams of their own to use, and I get them to make a square with all 7 tans. We do other puzzles too, like make a right triangle. I just love doing some puzzles with the kids. This is not a strength for me, which is nice for the kids to see. I struggle with the puzzles, but I get better and keep trying, and the students actually see that improvement, and they see me sticking with something and being okay with it taking longer. And that's a good message in growth mindset. This is also a chance for other students to shine. I find that with puzzles and spatial reasoning tasks, it's often a different bunch of students that show a real strength. And having students see the different ways we can be awesome at math is a positive thing. Using tangrams for fractions is great. They see that we can tell this amount is 1/4 since 4 pieces that size will take up this whole square that we're using to represent one whole. This triangle is 1/8 of the square because 8 pieces this size make one whole square. But using tangrams can also highlight the relationships to other pieces. Like this piece that's 1/8 is exactly half of 1/4. And they can see that relationship. They can also see that different shaped pieces could be named with the same fraction. And we talk about those relationships and why they make sense. After we have some comfort with the tangrams and fractional amounts we can assign to each piece, I use some pictures like this from fractiontalks.com. We talk about the total of this blue shaded space and how they know. I usually have this projected on a screen and students come up and draw lines and talk it through and show others how they thought about it. Here's another one from fractiontalks.com, and I try to switch up the directions a little bit to keep those students on their toes. I also extend to other fraction squares like these. We assign fractional amounts to each of the pieces and explain how we know. It is amazing how many different ways students can see these relationships and how quickly their skills improve. We also extend into adding, since the pieces in this half, for example, should have a sum of 1/2, and that should be equal to this side. I've also used the fraction squares at fractiontalks.com to create a 2 truths and a lie activity for fractions. 2 truths and a lie is another routine I use a lot. I have collections made for each unit. You may have seen one of my 2 truths and a lie activities on the HRCE website for provincial testing prep, but I also use questions like these individually as warm-ups outside of their units to keep the ideas fresh. Here are some of the cards I made in the fraction set. Let's listen in on some students figuring things out.
The yellow is 1/2 of the purple, not the teal. 1/3.
Okay, can you tell me why you know that?
Because this is equal to this.
Yep.
And then there's this left over, and this makes this. So this makes this, which makes this half of it.
Says the red and green together cover 5/8 of the space. So this is 1/4 here. So half it up would be an eighth and an eighth. So 1/8, 2/8, 3/8, 4/8, and then these up here are together would make another eighth. So it's 1/8, 2/8, 3/8, 4/8, 5/8. So that's true.
Okay. Kyle, why don't you tell me about another one?
So the red space is 1/16 less than the green. So if that was 2/8, and then if I was to break that down again, that would be 4/16, right? So then the green space would be, so that's 2/8, and then that's another 2/8 would be 4/8, and then double that. No.
That's 3/8 right here. That's 1/8, 2/8, 3/8.
Oh yeah. Okay, yeah. So 3/8, and then that's 4/16. So yeah, so that'd be 6/16. So that's wrong.
And then,
Okay. I like that. That was a different way of
Last one,
explaining that I heard.
The green space is 1/8 more than the red, so it was 1/8, 2/8, 3/8, and then 1/8 and 2/8. So then that's 3, and then this 3/8, that's 2/8. So this is one more eighth than that one and that. So see.
Wasn't that great? It's so fun to listen to student explanations. I hope you could hear them. There's lots of other great conversations in the background. I often record student ideas and reflect later on what they know and what I should do next to help move their thinking forward. It's also fun for students to hear their first explanations and compare them to what they might say later on in the unit. So fraction squares coupled with 2 truths and a lie works great. The kids really seem to love it, but sometimes not all kids are ready for these questions. So to open this activity up, we could just put up a fraction square and ask students to say something true about it. This provides a low entry, high ceiling scenario where all students have an access point and can participate at their own level. So those are some of my ideas around fraction talks. I use lots of pictures and manipulatives to help concepts make sense and really stick long term. I start really simple and build gradually, always tailoring activities to the current needs of my students. I get students chatting in small groups and also sharing out as a whole class. So lots of different ways of seeing these pictures and relationships are shared. And it's a better chance of all students finding a method that works for them and fits with their reasoning. I think it might be time to wrap up my session on warm-up routines. I have lots of other favorites, like which one doesn't belong, open middle problems, and warm-ups using manipulatives or number lines where there are many possible answers. I'll save those for another day. I hope you found at least one thing that you liked and might like to try. I would love some feedback on what you heard here today. If there was a routine you'd like to talk more about, or if you'd like to collaborate on creating something for your class, please reach out. I really do feel that warm-ups are a great way to help students see connections and build a deeper understanding of math concepts, as well as building number sense, confidence, community, and engagement. Thanks for listening.